Right, grade 11. So moving on to topic 3.2, which is also about the sine rule, but this is called the ambiguous case of the sine rule. Now I'm just going to start this by clarifying that I've never seen this asked, and so this is not a massively important concept. So we're just going to do one or two examples and let you do one example because it does exist, but it's very much not an important part of 2D trig. And so when you look at past papers, you'll see this come up very, very rarely. Okay, now what does it say? Basically, so far, when we did questions that involved the sine rule, it was quite obvious to us that if we landed up with an equation of sine, that there were two possible solutions. However, because up until now there's always been a picture drawn, it hasn't been ambiguous as to which one of the answers is actually correct. Because a picture was drawn, it's obvious to see whether the angle is obtuse or acute, and so far we've been picking the correct solution that matches the picture. However, what happens if they give you information and they have not drawn a picture for you? Sometimes it is possible to draw two different possibilities that fit the given information. So let's have a look at an example. If you're given a triangle ABC and all you're told is A, which is opposite vertex A, is 50 millimeters, B, which is opposite vertex B, is 30 millimeters, and the angle at B is 30 degrees. How do you draw this? Now what I did is I drew this on a graphing program, and the first thing that I did was I drew a long line at the bottom of where the triangle would be. Then I drew an angle of 30 degrees because I was told that the angle at B is 30. I was also told that opposite vertex A is 50 millimeters, so it will be 50 millimeters from B up to point C. So that had to be there, that was fixed. It's at an angle of 30 degrees and it's 50 millimeters. So that BC can't move at all. Now I'm now told that from C down to A would be the side of B, baby B, and that's 30 millimeters. So when I was drawing this, I thought of C as the center of my circle, and I drew a circle on my graphing package that you can see I've still got it dotted in grey. I drew a circle with radius 30 millimeters because then I could see where would a length of 30 millimeters hit the bottom line of the triangle. And there were two options. Either that angle, that side of C, and I've called it A dash, that could have been 30 millimeters down to the base of the triangle. However, there's a second spot. If I drew 30 millimeters and formed an acute angle triangle, that would go kind of slanting downwards to form what I've called vertex A and not A dashed. So basically, there were two possibilities. And so what I did then is kind of copied out each one, and I've placed them separately next to one another. So given the information that was written, it is possible to draw two different triangles. Now, the good news is this doesn't always happen. It's a very specific kind of restrictions that have to be met in order for there to actually be two possibilities that could be drawn. So, when does this happen? This only happens when you're given two sides. So you have to be given the lengths of two sides and one angle. And the side opposite the angle given has to be the shorter of the two sides. That's when you know that it actually is possible to draw two different possible triangles. So let me just say that again. You were given here, I was given the lengths of two of the sides and I was given an angle. But the angle was opposite the shorter of the two sides. And hence, there are two possibilities that could have been drawn. Now the hard part is knowing to look for two possibilities. Actually working out the maths behind the two possibilities is really easy. So in the above example now, we're going to determine two possible values for A and then two possible values for BA. So there's angle A. Now immediately I have a pair because I have 30 degrees and I have the side opposite it, and that's true in both triangles. So I'm thinking this looks like a good case of the sine rule. I also have 50 and I'm looking for the angle opposite the 50 in both triangles. So the solution in both triangles doesn't look any different. So if I'm looking for angle A, I'm going to start with sine of angle A on top, And the sine rule says sine of angle A divided by the side opposite it would be equal to sine of 30 divided by the side opposite it. And that's true in both of these triangles. Now if I multiply by 50 on both sides, I get the fact that sine of angle A is equal to 5 over 6. Now we've already seen this before. We know that a sine equation can possibly have two answers, and so far we've known which one to pick. So how do I find my two possible answers? Well, my first possible answer would be shift sine of this 5 over 6, and that gives me an angle of 56,44 degrees. Now that would be an acute angle. So if I look at the picture, what angle is that? Well, that's the option that I drew in the second triangle, because that's an acute angle. Now, or my second option is, we've been solving this for ages, the angle which must be at A dashed would be the obtuse angle, which is 180 minus that 56.44, which is 123,56 degrees, which will be that option. So mathematically it's very easy. It's the same sine rule. It's just that we've got to remember that a sine equation can have two answers. Now I just want to say this again. 99 times out of 100, you'll never see this. 99 times out of 100, the picture is there, and so it's very easy to tell which one of these solutions you need. And most likely they always go for the acute angle because they've drawn an acute angle triangle. Okay, now that we've found both of those, we apparently now need to find the length of BA. Now BA is opposite angle C, which means we now need to work out the two different options for angle C. There's two different options because sum of angles in a triangle is going to get me two different answers based on the two different options for A. So if I look at my acute angle triangle, here I would do 180 minus 56.44 and then minus my 30 degrees, and so I would get a C value of 93,6 degrees, and that is sum of angles in triangle. Now I've just realized it's not 0.6, sorry, my mental math's letting me down. It's 93,56 degrees. Now my second option is I could have found angle C in the first triangle by doing 180 minus 123,56 minus 30, and I would have got 26,44 degrees. So there's two completely different possibilities. So sum of angles in my triangle. But what that means now, in finding BA, I'm going to have to do two separate sine rule examples, because there's angle C and opposite is AB. So if I want to find, let me do my acute angle triangle first. So if I want to find AB, AB is opposite angle C, so this is sine of 93,56, and that'll be equal to, and I always pick the ones I was given. I was given 30 opposite sine 30, so I'm going to use that. So that'll be equal to 30, but that's opposite sine of 30 degrees. So I multiply by sine of 93,56 on both sides, and I get 59,88. Now in the other triangle I'm going to do exactly the same sine rule, except this time when I have AB, angle C opposite AB in this triangle is now 26,44, but it's still equal to 30 over sine 30. So when I multiply now by sine of 26,44 on both sides, I get 26,72. Now that makes complete sense, because if I look in my obtuse angle triangle, it's a lot smaller, this AB value. Because it's opposite an angle which is an acute angle, it does make sense that it's a lot smaller. Now the reason why we don't like to assess this is that, as you can see, you're doing exactly the same thing twice. And we try not to assess in an exam something twice, because if you can't do it the first time, you can't do it the second time. Which is why I have no problems with saying determine two possible values for A, because that's assessing your idea of, do you know that a sine equation has two answers? But to ask for two possible values of BA isn't really mathematically anything new each time. So that's why this is quite rare to be asked. So we're only going to do one more example because it isn't commonly asked. Now notice I these options only occur when you haven't drawn the picture, because the moment I've drawn a picture, I'm deciding whether it's the one solution or the other. So in triangle PQR, Q is equal to 95, R is equal to 70, R is equal to 46. Determine two possible angles for angle P. So I always start with R because that's what was given to me, and I draw a whole long line that goes all the way across. So somewhere near there is the bottom of the triangle. Now I was told that 46 degrees, so I would measure 46 degrees if I was actually doing this. And P is obviously going to be somewhere along this line, so I must go all the way up to Q. So let me think, R, so opposite R, and this is, so Q is 95, so I'm going to go all the way up there. Let's pretend that is 95 millimeters, and that won't be to Q, sorry, that'll be to P, and then Q must be somewhere down along this line. I do know that R is 70, so opposite this R, now why am I knowing that I need to draw two possibilities? Well, number one, it said two possibilities, but number two, you are given two sides and an angle, and this angle is opposite the shorter side. So basically, either the 70 is going to be able to be drawn like that, and then P would be there, I'm going to call him P dashed, or 70 could go down this way, and then that would be P. Oh, why am I writing P? I retract that, let me start again. This would be Q dash, sorry, and this would be Q. So both of these are 70. So there's two possibilities that could happen. Sometimes it's helpful to draw them separately, so I'm actually going to do that. I'm going to say, right, either it's going to be an obtuse angle triangle like that, and what I know is that this is 46, this is 95, and this is 70. Or my other option could be an acute angle triangle with exactly the same stats. This is 46, this is 70, and this is 95. Now this is R, Q, and P. Right, so I'm basically going to set up exactly the same sine wall because it's the same information. Now the pair that I've got is I've got 46 opposite 70, 46 opposite 70. Now 95, the only other thing I have is opposite Q. So I can't actually solve for P first, I have to solve for Q. So I'm going to start this, always start on top with what you want. So sine of angle Q over 95 is going to be equal to sine of 46 over 70. So when I multiply by 95 on both sides, regardless of which triangle you were thinking about, you get sine of Q is 0.9762 blah 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 blah. Now that's not what I wanted, I want the value of Q. So if I shift sign answer, I get angle Q is equal to 77,48699. So let me just keep it a couple of decimal places. Now that will be the acute angle. Or I would do 180 minus that, which is the second angle, which actually would be angle Q, what I called dash. Let me put my dash in. And that will be 102,513,004. And that will be my obtuse angle. Now in both of these cases, all I need to do in solving for P is use sum of angles in a triangle. So in the first, 180 minus 77.486 minus the 46, I get 56,51 degrees. Sum of angles in a triangle, don't forget your reason. And by exactly the same reason, I would get 31,49 degrees because of sum of angles in triangle. So that's a pretty nice question because you're not doing too many steps twice because we don't want to assess that. So summary of the ambiguous case. The ambiguous case, if I scroll up to the note, if you are not given a picture and you don't know what the picture looks like, if you're given two sides and one angle, and the side that you're given opposite the angle is the shorter of the two sides, there are actually two possible triangles that you can draw. And so you need to draw two possible triangles because it lands up giving you two sets of information on what remains. As I've said though, very rarely asked because mostly they've got a picture and then you can tell which solution to the equation that they need.